Hi, it's Joshua coming to you from here in Abbotsford, British Columbia. And what you see before you is the star stove that eventually, when it's complete, will form a kitchen with 7 separate appliances. And I don't have my cameraman here today, so I'm going to have to try to do this one-handed. Okay, this is the star stove, the base plate, and it's made out of 1/4 inch metal, and from point to point it's 16 inches and roughly 14 inches across, so it's about 20 pounds of metal. And in the center here, this is where the air and the fuel would come into the back. I'm just using my relocation platform just for a demo, so it makes it work. So you got your air and your propane coming through, and you want your top plate. Your top plate is also 1/4 inch metal, made the same shape. So once you got your propane, or you have your propane on about 50%, and then you would turn your air on just low. You want low pressure air when you're first starting it. Then you would light the edge, and you get your mostly yellow and blue flame coming out, going out 6 to 7 inches or so. Then as you tune down the pressure on your fuel and air, you can actually see where it begins to form a band of blue. So this is still the propane burning. You're not getting no hydrogen production at this point. And when you draw so this would be the level 1 going into a level 2. And when you draw your flame back inside, it produces your level 3. And at that point, you can turn up the stove, turn up the air pressure, and adjust the propane to whatever desired effect that you have. But it would cause the flame to come back out. But also, it's heating. The flame is actually going through the center of these 2 plates. So what you would see, I'll grab my other piece here, it would look like something like this. So when you have your level 3 beefed up, you'd actually get a hydrogen burn on the outside. And why I say that is because of the water inside that's being formed from the production of the burning of the propane and air, and releases water, and that water, the oxygen part, combines with the iron to begin to rust the in between the 2 iron plates, and that frees up the hydrogen. So the hydrogen is going to look for the easiest place to burn, and so you would have more of a hydrogen flame here than you would a propane flame. And so your distance all the way around, this would be 8 inches per side, so 8 times 6, 42 inches. We'd have 42 inches of flame. Okay, there's one more modification you can do to this, and that's putting in another plenum on top, and this could be this size, or you could make it larger. So basically, this is all welded on, and you would have your air going into there, into the plenum. So that would charge this with air. Then you could have 3 injectors for injecting diesel or gasoline or whatever. You could use a Coleman camp stove also to charge these up. So what would happen when when you inject the fuel in, you would touch the hot portion of the stove, and that would cause it to volatilize. Then you could have, say, hose metered through the stove that would allow the vapor gas to be mixed with the propane. And if you designed it right, you'd be able to inject diesel or gas in any 6 of these quadrants of the stove to increase the heat of the flame. So you could actually have 6 different temperatures coming out just by adjusting the amount of volatilized fuel that goes into this section, or this section. That's what I'm planning to do. And what I'm hoping as a further addition, if it works, I want to use the other 3 quadrants. This is going to be expanded, of course, to generate fuel as a auxiliary. And you might ask yourself, well, what purpose would that serve? Well, you'd be able to maybe run a 1 kilowatt or maybe 2 kilowatt generator with it, so you would have power at the same time. So your main fuel in this is a 20-pound tank of propane that's burning very efficiently, and you could say about 1/3 would be propane, and 2/3 could be injected diesel or gases or waste oil, where the CO2 is mixed with your carbon in between the plates, or with your CO2 is mixed with your hydrogen to form carbon monoxide, and water. You might get more hydrogen production. You might get some methane production if you're using injected fuels. All right, I'm just doing this as an intro. I would like your feedback on this, and this helps me to further advance this work. This is Joshua coming to you from Abbotsford, British Columbia, with the presentation of the Star Stove.